All right, let's move on to section 1.4, single variable expressions. We're going to start to see some letters crop up in our math, and that's kind of exciting. Let's take a look at an example here. We're going to look at our friend Shelly. And Shelly makes bracelets. Now, Shelly spent $150 on supplies to make her bracelets, because she's making a bunch of them. And every time she sells a bracelet, she makes $4. So we could model the how much money she makes by an expression that looks like this. It looks like 4b minus 150. And we'll be talking in the coming chapters and coming sections on how to make this expression. But for today, we'll just be given it. And the question is, how much money did she make if she sold 50 bracelets? Oop, not $50, 50 bracelets. Well, before we can solve this, we're going to have to do a little bit of defining terms before we move on here. So the first thing we're going to talk about is an expression. An expression in math is different than it is in Writer's Workshop. When an expression is, oh, that's just an expression, we just say that. An expression has a discrete and absolute meaning in math, as most things do. An expression is simply a mathematical phrase that has numbers and operations. It also has numbers, operations, and typically variables, but not always. Some examples of some expressions might look like this. 3x plus 10. Negative 15 plus 7 minus 1. 5 squared minus 1, or 15r plus 2. So you can see that sometimes it has a variables, but sometimes it doesn't. And variables, sometimes. We'll add that to it. Now, what we can do is we can take expressions and we can simplify them. We can't solve expressions because there's no equal sign, so we can't solve for anything. But we can simplify and we can evaluate. And these are important terms to know the difference of, because when we're looking at expressions, we can only do these certain things. For example, I could take the expression that I have here, this negative 15 plus 7 minus 1, and I could rewrite this, I could simplify it into a more easy to look at term. Negative 15 plus 7 is negative 8, minus 1 is negative 9. So I could say that negative 15 plus 7 minus 1 is the same as negative 9, and in fact it's simplified, but I wouldn't be able to do any solving. Or I could take one of these other ones, and I can't simplify them any smaller, and that's kind of the point. Now, we have regular expressions, and we also have something called a variable expression. These include symbols to represent numbers. So they are expressions that include symbols to represent numbers. So some of the expressions that we had earlier in our example list were variable expressions, but some of them were not. Some examples could again look like this. We could have 3x plus 10. We could have 10r, b cubed plus 3, mx minus 3. All of these are variable expressions because they include symbols to represent numbers. Now, sometimes you can even see things that are not typically letters that we're used to. You could have 5 theta, which is another number that's in ancient Greek, or you could have 3 delta over 4. Delta is another number that we could see. And these, all they do is represent numbers that could fit into this expression. And that's kind of the important point. Now, today we're going to be talking about evaluating expressions. Now, this stuff is pretty simple, which is pretty convenient. But let's take a look at one quick example, and let's in fact go back to Shelley and her bracelets. The expression that was given to us was 4b minus 150. Now recall that 4b is really equal to 4 times b, but when we use variables, we don't need to write that multiplication anymore. We call this the implied multiplication. That's because in math, typically we use multiplication more than any of the other operations, and mathematicians are inherently very lazy, and they just don't like to write the things that they use most of the time. So if you ever see a number mashed together with a variable like that, it's just assume that it's going to be multiplied. And they told us that B, or the bracelets she sold, was equal to 50. So in order to evaluate this, all we're going to do is we're going to plug this 50 in to our expression. So what I'll be looking for on your page is just simply this. 4b minus 150. Now I'm going to substitute it in. And when I substitute things into expressions like this, I like to use parentheses, but you don't have to. So I like to write it like this. 4 times 50, because remember, whenever there's two numbers next to each other like that, there's an implied multiplication, minus 150. And now that they're all just regular numbers, I'm able to evaluate and see what I've got. Let me pull up my calculator. Keep in mind, though, I do need to do my order of operations. So that means I have to do my multiplication first before I can do any of my subtraction. So 4 times 50, I can do that. I can do that on my calculator, or I might know that one. That one's going to be 200 minus 150. Notice how I bring it down to get to the next level. Now I can do 200 minus 150, which gives me 50. And that tells me that Shelley made $50 on this bracelet endeavor of hers, which is pretty good. All right, that's example 1. If you feel like you kind of get it, go ahead and go on. I'm going to do probably a couple of more. Example 2. Let's take a look at this. It says, evaluate x over 7 minus 5 when x equals 49. Okay, easy enough. Let me substitute this in. I've got 49 over 7 minus 5. Okay, I have to do my 49 over 7 first because division is before subtraction. I know this one in my head because I know 7's this perfect square of 7, or 7 squared, is 49. So I can say that that is 7 minus 5 if I bring this down to my next layer. 7 minus 5 is 2, and when I've got my answer, I usually like to box it up. Looks like I forgot to do that in my last one. How it goes. So let's take a look at one more. Example 3. Here we'll take a look at 4x minus 9. X is equal to 20. Okay, I'm going to substitute it in just like I did before. 4 times 20 minus 9. 4 times 20, I can do that in my head if I remember the 0 rule. 4 times 2 is 8. Put the 8 back on. I've got 80 minus 9. 80 minus 9 is going to give me 71, which gives me my answer. With those couple of examples, we should be able to figure this out. If not, that's okay. Ask a friend or ask me for help. Go ahead and good luck.